Good afternoon. Today we will see the different factors, that is neutral axis factor, lever arm factor, moment of resistance factor. So three factors: neutral axis factor, then lever arm factor, and third moment of resistance factor, and fourth we are going to see formula for AST, that is area of steel in tension. So now in last lecture we have this formula for Cu 0.36 FCK XU. Then it will act at 0.42 XU from top, and we have seen it is in a rectangular part. It is in rectangular part. We have seen we have depth of rectangular part is 0.429 XU. And we have this value, that is 0.416 XU. So this is less than the depth of rectangular section. So Cu will act in rectangular part. Now we have also seen formula for Xu by equating Cu equal to Tu, that is 0.87 FYAST upon 0.36 FCKB. Then we have also seen this moment of resistance by calculating the couple Cu into lever arm, and that is equal to Tu into lever arm. Lever arm we have D minus 0.42 XU. So now we have also seen last time we have Ku max, that is equal to 700 upon 1100 plus 0.87 Fy. So now from this, so neutral axis factor, this is Ku max, which we have calculated in last lecture, and that is nothing but lever arm factor. And this we have calculated. So we have two way. So this is 0.0035 divided by 0.0055 plus 0.87 Fy upon ES. This is one way you can calculate Ku max value, and another way also we have seen we have Ku max, that is equal to 700 divided by 1100 plus 0.87 Fy. So from this formula it is very clear that my lever arm factor is independent of grade of concrete. Independent of grade of concrete, or I can write it depends only on grade of steel. It depends only on grade of steel. Grade of steel. So this is first. Then second we have lever arm factor. So now we have calculated lever arm, we have D minus 0.42 XU. So this I will say as max. This is 0.42 XU max. We are calculating critical. Critical means for balance section. So we have lever arm equal to D minus 0.42 XU max. But we have already seen Ku max, that is equal to Xu max upon D. And then from this we can write D is equal to, Xu max equal to Ku max into D. And this value we will substitute in this equation, and therefore we will get lever arm equal to D minus 0.42 into Ku max into D. And that will gives us, if I will take D outside, we have 1 minus 0.42 Ku max. And this 0.42 Ku max, this is your lever arm factor. So we have lever arm factor, generally denoted by Ju max, which is equal to 1 minus 0.42 Ku max. And from this we can write lever arm equal to Ju max into D. So lever arm factor we have very clear, that is 1 minus 0.42 XU max. Now we will switch over to the third factor. Now this is moment of resistance factor. So we have third factor, moment of resistance factor. Now we have seen what is moment of resistance. So we have mu max, that is equal to 0.36 FCK B into XU max in bracket D minus 0.42 XU max. Now we will put a value in terms of Ku max. So 0.36 FCKB into Ku max into D in bracket D minus 0.42 Ku max into D. And then from this we will get 0.36 FCK Ku max in bracket 1 minus 0.42 Ku max into Bd square. Now we know we have this as Ju max, so we will put it 0.36 FCK Ku max into Ju max into Bd square, and this is known as Ru max into Bd square, and therefore we can write moment of resistance factor, which is equal to Ru max, and that is equal to 0.36 FCK into Ku max in bracket 1 minus 0.42 Ku max, or we can write it as like this also, 0.36 FCK Ku max into Ju max. So this is formula for moment of resistance factor. So we have these three factors, and we should know formula for three factors. Now we will switch over to the form, that is area of reinforcement. Now we have mu equal to 0.87 FYAST. Two formulas we have. We are interested with AST, so we are taking formula related with AST for mu. Now we have also Cu equal to Tu, and from this we will get Xu, that is equal to 0.87 FYAST divided by 0.36 FCK into B. Now this value of Xu we will put in this equation. Then we will get it as mu is equal to 0.87 FYAST in bracket d minus 0.42 into 0.87 FYAST divided by 0.36 FCK into B. Now rearrange the terms. So we are taking this as LCM. So we will get it as mu into 0.36 FCK into B, which is equal to 0.87 FYAST in bracket D into 0.36 FCK into B minus 0.42 into 0.87 FYAST. Now you simplify this. By simplifying, we will get it as 0.318. So we will have 0.318 Fy square upon AST square. So if we multiply this with this term, we will have 0.87 into 0.42 into 0.87. It comes as 0.318. Then we have Fy and Fy square and AST into AST. So we have AST square. So this comes on the left side becomes plus. Then we have second term. This is 0.87 FYST into this part. So comes on left becomes minus, and that will be 0.313. Then we have Fy into FCK into B, FCK into B into AST, and plus we have 0.36 FCK into B into mu, which is equal to 0. So in this we will get A. So this will be equation, quadratic equation in terms of AST. And in this we will get, this will be my value of A, which will be equal to 0.318 into Fy square. Value of B we have this one. So we have B equal to minus 0.313 Fy FCK into B, and C value I have 0.36 FCK B into mu. And then by using equation, that is xu is equal to minus b plus minus root of b square minus 4ac upon 2a. And if I will put these all values in this, I will get xu is equal to minus b we have minus 0.313 fy fck into b minus b plus minus, then we have a root of b square, means we have minus 0.313 fy into fck into b whole square, b square, then minus 4, a value we have 0.318 into fy square, and C value we have 0.36 FCK B into mu divided by 2A. Now A we know, we have 0.318 Fy square. And now you solve this, and by solving this, we are going to get value of AST, that is equal to 0.5 FCK BD divided by Fy in bracket 1 minus root of 1 minus 4.6 mu divided by FCKBD square. And this is formula for AST. So this AST formula we have to use in beams, in slabs. So everywhere we have to go with this formula of AST. So we will stop here only today. So thank you.